Okay, let's give you guys some more practice. So remember the gradient of this represents the speed. The gradient of the speed time graph represents the acceleration. Okay, so bear that in mind. Here's a tough question. Given this random graph here, what is the acceleration at time equals 2? So what is the acceleration right here? Okay, so hang on. As a quick reminder, the um, the gradient of this represents the speed. The gradient of the speed time graph represents the acceleration. Okay, so same as over here. The gradient of the distance time graph represents the speed. The gradient of the speed time graph represents the acceleration. So looking at this here, given this random graph, what is the acceleration at time equals 2? Okay, so press pause and have a go. Okay, at time equals 2. If you look at this, it's a straight line here. It's a straight line. So it's a straight line here. So if you look at this here, hang on. So remember, I've given you a distance time graph, and it's a straight line. Okay, so what I've given you is a distance time graph. So it's one of these two here. But what I've given you is a straight line. You see, if it's a straight line like this, then that can only mean it's under constant speed. Well, if the speed is constant, then the acceleration must be 0. So here the acceleration is 0. In order for it to have an acceleration, the distance time graph would have to be in a way a quadratic. It has to be a curvy line like this. What I've given you is a straight line here. Well, if it's a straight line here, it must mean it's going at a constant speed. Well, if it's going at a constant speed, there must be 0 acceleration. If there were an acceleration, then it means the speed is increasing. If the speed is increasing, then the distance time graph will look like a quadratic in a way. So what I've given you is a straight line here. So to answer this question here, the acceleration here, well, I've given you the distance time graph. This here would imply that because it's a straight line here, it would imply that the speed time graph. So what I've given you is a distance time graph. I've given you this one here. Because it's a straight line, it would imply that the speed time graph, the speed would be constant. Well, if the speed is constant, then the acceleration must be 0. Well, to answer this question here, the acceleration is 0. Okay. Next question here. Given this random graph, what is the speed at time equals 7? So press pause and have a go. So time equals 7 here. What is the speed there? So press pause and have a go. Okay, so picture the 3 graphs in your mind. Which one have I given you? I've given you the distance time graph. I've given you this graph here. So I've given you the distance time graph, but I'm asking you about the speed. So the gradient of the distance time graph represents the speed. So really, to answer this question here, so at time equals 7, you want to know the gradient at this point here. Okay, well the gradient at this point here is the same as the gradient at this point here. That's the same as the gradient at this point here. Well, anyway, just find out the gradient anywhere on that line. So maybe you can use this triangle here. The up and down is 3. The across here is 2. So the speed will be 3 over 2 meters per second. Okay. Next one. Given this random graph, what is the distance traveled between t equals 4 and t equals 5? So 4 and 5 here. What is the distance traveled? Okay. So press pause and have a go. Okay. So given this speed time graph, so in your mind, picture the 3 graphs. I've given you the speed time graph. I've given you this graph, but yet I'm asking about the distance. So you need to know the area underneath. Well, the area underneath the speed time graph represents the distance traveled. So the distance traveled is really the area underneath the speed time graph. So it's really you trying to find out this area here. So if a car is going at a constant speed of 2 meters per second, then in a gap of 1 second it would have traveled 2 meters. So the answer here is really the area underneath this graph here, which is 2. Okay, because the up and down is 2, the across here is 1. So the answer here is 2 meters. Okay.